Hi everybody, Ms. Maritello here. In this video I want to talk about how to multiply and divide numbers in scientific notation. I do want to start this video off very basic. So the first problem that we're going to look at just says 4 friends, Christy, Marianne, Claudia, and Stacy all babysit. If each of them made $18 last week, how much money would they make all together? So if you want to try that problem on your own, you can. I figure we have 4 friends that are each making $18. The most efficient way is probably to multiply 18 by 4. You should get $72 from that. The reason that I bring this problem up, even though it's kind of easy, is I just want to bring up the idea that when you're looking at a word problem, don't just assume like that because we did, a couple multiplication problems that every problem's like that, because we're going to be seeing word problems that have addition, subtraction, multiplication, and division. So you want to be considering as you're going through these which operation would be most appropriate to use. So for example, when I have the next one then, it says a large corporation has approximately 2 times 10 to the 5th employees. If each employee makes about 5.4 times 10 to the 4th dollars a year, how much money would the employees earn altogether? And so something that I'm trying to kind of emphasize is as you're looking at these problems, sometimes when you see the scientific notation, it can be hard to figure out which operation you're going to need to use. But if I thought about it with just easy numbers, say that it was a large corporation or just a corporation maybe has 10 employees and each employee made, say, I don't know, $5 an hour just to keep it easy. If you had 10 employees and they each made $5 an hour, then altogether that would be like $50 an hour. Again, because 10 employees making $5 an hour. So you would be using multiplication. So now we have more difficult numbers when you look at the scientific notation, but you would still be using the same type of operation. So when we look at this problem, again, hopefully you should be seeing you would want to use multiplication to figure out how much money the employees would earn altogether. So if I'm multiplying those two numbers together, and if it helps you to even think about the numbers in standard form, you could. So on this slide, I actually started including that. So the 2 times 10 to the 5th is kind of like 200,000 employees. And then the 5.4 times 10 to the 4th dollars, that's like $54,000 a year. So we should hopefully see that we're going to be getting a pretty big number for our answer if we have 200,000 people each making $54,000 a year. So when you think about this problem then, so 2 times 10 to the 5th times 5.4 times 10 to the 4th, if you want to try to attempt it on your own before we go through it, together you can, but I'm hoping you realize that the answer is going to be a pretty big amount of money. I really like going through it by kind of rearranging it. And I know whenever I have multiplication, I'm allowed to rewrite the numbers in any order that I want. So I'm actually going to put the first factors together. So I'm putting the 2 times 5.4 together, and then I'm going to put the powers of 10 together. So 10 to the 5th times 10 to the 4th, I'm going to put next to each other. You don't have to do that, but I just think it makes it look a little bit easier. And technically, I am allowed to multiply the numbers in any order that I want, but I personally think it's easier if we can combine them, like the first factors together and then look at the powers of 10. So I know that 2 times 5.4 is going to be 10.8. And then if I was to do 10 to the 5th times 10 to the 4th, you should be seeing that you're multiplying numbers where you have the same base with different exponents. So that's going to be where you add together the exponents. Please keep in mind that this is not like adding and subtracting numbers in scientific notation where you're just keeping the same exponent or you need the same exponent to go through it. This is different because when we're multiplying numbers, you can multiply the numbers in any order that you want. When we were adding or subtracting numbers, it was kind of like you were doing like 10a minus 8a and you just got 2a. This isn't like that because it's multiplication. So this is going to be a different set of rules for multiplying and dividing numbers that are in scientific notation. But so again, I would multiply your first factors first. So 2 times 5.4 is going to get you 10.8. And then when you combine 10 to the 5th with 10 to the 4th, you should be adding together the exponents. That would give you 10 to the 9th. You almost are done, but hopefully you're noticing when you see that 10.8 times 10 to the 9th, that number is not in scientific notation and it's not really in standard form either. So you have the option to kind of use the shortcut to put it into standard. Well, either use the shortcut to put it in the correct scientific notation, or you can put it into standard form and then back into scientific notation if you want to. So if you were just to put that number into standard form, from there, then you'd have to move the decimal 9 places to make it a big number. You know it's going to be a big number because the exponent's positive. So that would give you technically, it would be $10,800,000,000, which makes sense. We said it was going to be a really big amount of money if you had 200,000 employees all making $54,000 a year. But then if you actually wanted to put that into scientific notation, you could put it back into scientific notation from there. You would need the decimal to be in between the 1 and the 0. So then that would make your new first factor 1.08. And then you'd be moving the decimal 10 times to get there. So you know you would have 1.08 times 10 to the 10th, and that would be dollars. Or if you wanted to kind of do the shortcut, you would hopefully just see that you need to move the decimal one place to the left, which would be like dividing by 10. But the opposite of dividing by 10 is multiplying by 10. And we need to do the opposite to keep it balanced, keep the number the same value. So if we're dividing by 10, it's like you need to multiply by another 10 over here. So then when you would do 10 to the 9 times another 10, that would be what would make it 10 to the 10th. And again, notice this one, I'm making sure I'm labeling it with dollars. And I know sometimes people ask me, what if you gave like the standard form instead of the scientific notation? Either of those two answers really should be acceptable because they don't say to put your answer in scientific notation or to put it in standard form. Taking a look at our next one, this is like another basic review, and I really want you guys, when you read these problems, I want you to kind of compare them and see what's different. If you want to take a second to pause this to take a longer look, you can. Hopefully you're seeing, both of them say that Kelly baked 24 cupcakes for her sister's birthday and John bought 6 cupcakes at the store, or at the Jewel. But the first question just says, how many more cupcakes did Kelly buy than John? Whereas the second question says, how many times more did Kelly buy than John? So when we're looking at this one, if they're asking you just how many more cupcakes, that should be subtraction. So we're going to do the 24 minus 6, and we should get that she would have bought or made 18 more cupcakes than John did. But when we're looking for the second one at how here they're asking how many times more, then you're going to have to do division. Because if I want to figure out how many times more, well, 24 divided by 6 gives me 4. So I know sometimes people think for this one, like you have to multiply that because they hear the word times. But if you're figuring out how many times more, that's when you have to divide. And then it's kind of just like your double check is, well, 4 times 6 is 24. But to actually come up with the 4, you have to do division. So 24 divided by 6. But something that I really like highlighting here is just when we're hearing that how many more cupcakes, that's when we're doing the subtraction. But for how many times more, that's when we're doing division. And the other thing that I want to highlight with these two review problems before we move on to the ones with scientific notation is that when I label my answer for the first one, it's just that like Kelly, she bought 18 or she brought to the party 18 more cupcakes. But for the second one, though, it's how many times more cupcakes. So here it should be that Kelly brought 4 times more cupcakes. I couldn't say Kelly brought 4 more cupcakes because that wouldn't be correct. She didn't bring 4 more cupcakes. She brought 4 times more cupcakes. So you got to pay attention to the labels with some of these problems just because it's not always going to be whatever the label was here. Sometimes it might be like so many times more. So looking at the next problem, and I actually already set it up for us, but it says Patrick Kane's annual salary is about 6.2 times 10 to the $6, and then we have Chris Bryant's annual salary is about 18.6 times 10 to the $6. And yes, I know that that number, it's not in scientific notation, but I did it that way because the numbers are going to be easier for us to look at. And then it says Chris's salary is about how many times greater than Patrick's. So we're seeing that how many times greater that we just talked about with the previous question. So as soon as I see how many times greater, I'm going to set it up as a division problem. I really like writing it as a fraction just because it lines up the first factors and the powers of 10 really nicely. And then the other thing that I wanted to point out is they're saying Chris's salary is about how many times more than Patrick's. So then I have to put Chris's salary in the numerator and Patrick's salary in the denominator. So they're comparing Chris with Patrick, so Chris goes in the numerator and then Patrick goes in the denominator. So from here then, hopefully you're seeing kind of like the multiplication problems. I'm seeing the first factors are kind of close by each other, powers of 10 are close by each other. That's what I want. Because then it hopefully should make you see that you're going to need to divide the first factors and divide the powers of 10. So when you do that then, 18.6 divided by 6.2 is going to be 3. And then when I'm dividing the powers of 10, I have the same basis. When I have the same basis, then I can do, with the same basis with division, I can do subtraction. So 6 minus 6 is 0, so this is technically 3 times 10 to the power of 0. So that technically is just the number of 3. If you really wanted to go step by step with it, you figure 10 to the power of 0 is just 1. So it's like 3 times 1, which is just 3. So then I have to make sure here I'm labeling it as it's 3 times greater. So Chris's salary is about 3 times greater than Patrick's. Again, keep in mind, if you labeled it as $3 greater, that would be wrong. It's about 3 times greater. And I have one more question for you guys in today's video. In this one, it's like a space problem, so it says the mass of the Earth is approximately 6 times 10 to the 24th kilograms. The mass of Pluto is approximately 1.5 times 10 to the 22nd kilograms. And we want to know about how many times more is the mass of the Earth than the mass of Pluto. And by the way, those numbers, they are approximated a little bit just so that they're pretty friendly for us. If you want to pause this one and try it on your own, you can. Hopefully you're seeing that when you go to set it up, because it's a how many times more problem, we're going to be dividing there. So they're asking us how many times more is the mass of the Earth than Pluto. So Earth's mass is going in the numerator, whereas Pluto's is going in the denominator. And then from there, I'm essentially going to be dividing my first factors and dividing my powers of 10. So 6 divided by 1.5 gives me 4. And then when I go to divide my powers of 10, again, I'm dividing the same basis. So I use subtraction, or I subtract the exponents as my shortcut. 24 minus 22 is 2. So that gives me 4 times 10 to the second. So then that means that the mass of the Earth is about 4 times 10 to the second times greater than the mass of Pluto. Technically, that would be acceptable to put. You also could put that it's 400 times greater, because 4 times 10 to the second is 400. So then we know that the mass of the Earth is about 400 times greater than the mass of Pluto. Hopefully this video was helpful for you guys. Thanks for watching.